Hello, I thought I'd share my little teardown here. This is a Sportsman 1000. Decided to see exactly what made it tick. Fuel tank there. I guess first I can show you that these two blue wires is a 12 volt DC circuit. And so the wires come out here to this little circuit breaker. And then it goes into this little bridge rectifier. And if anybody want to know the numbers, goes through this fuse and then to the DC plug. And this 12 volt system is completely separate from all the other systems, so they don't use the 12 volts for anything in the inverter. It's just a 4 amp 12 volt circuit for you to charge your battery, a 12 volt battery. So here, these are the leads that power your inverter. You have the 3 black ones that are, I think it's 420 volts AC, 3-phase. And these 2 white wires, I assume, are some type of DC generator, but I need to put it on a scope and see exactly what's coming out of there after I get her started. But I'm assuming that those 2 things are what create your 120 volt AC power in the end. So over here we have this white wire and this black wire. So the white wire is coming from your ignition coil, or I guess what do you call it? Over here you have that coil there, but I think it's getting the power from this white wire. But instead of having the coil with a magnet flying past it, it must just generate the electricity that comes down and goes into this little ignition module. And this black wire seems to be some type of, there's a gadget with a magnet on it, and then there's a high spot in the flywheel. So as the flywheel comes around, that high spot goes past the magnet, and it must create a pulse of electricity that comes down here. And as you can see, this ignition module has a condenser, a transformer, some type of MOSFET, and I'm not sure what that red thing is. Then it also has these LED lights. But I'm assuming that black wire triggers the MOSFET that then sends the energy to this coil here through the red wire and creates your spark. That wire comes up here to your spark plug. This green wire here simply goes to the ground. So, and there are some wires from this module here that goes over to the inverter, but I'm assuming, and I haven't tried it yet, that there's 2 wires here. Where'd they go? That if I jump her across them, I should be able to run this without, oh yeah, right here. I'm thinking that these 2 wires, if I jump her across them, it will run without the inverter. So I'm guessing that this is how the inverter can shut the thing off. Now these wires here, these also go to the inverter. The pink and the red one come from this switch, which is your eco mode. And these others, I'm guessing these run the LEDs. Because what controls the carburetor is the stepper motor. And it is a 12 volt stepper motor, but like I said, it's not getting its power from the 12 volt system, so it must be, the inverter must be creating the 12 volts. Let me turn this over here. And this just plugs into the inverter, so it's just, this stepper motor sits right there on top of the carburetor and adjusts the throttle position. And as far as the inverter goes, It is, according to the manual, a 700 watt inverter. This stator is stated to be a 800 watt, so I'm not sure how they get 1,000 maximum watts. But anyways, so you have the stepper motor drive here. You have the wires coming from the ignition module, and then you have the two wires that I assume are, because they come from, well, one of them comes from the on-off switch, and the other one goes to the ignition module. So that's why I think that this is just an on-off switch that's run by the inverter. So here you have your 3-phase AC coming out of your inverter, plugs in there, and then you have these white wires here, plugs in here. So I'm pretty sure that's just going to be like a DC generator, but time will tell. And I'll give you a little walk around here. So over here we have what I think a lot of people are calling a diaphragm fuel pump, but it appears what this does is it takes this vacuum from the intake manifold, and I think it uses a little diaphragm pump to actually just pull the vapors out of your gas tank here for probably emissions reasons, so your vapors don't go into the air and kill us all. Because the fuel pump, or the fuel comes through this line, and it just goes into the bottom of the carburetor here. And so I'm guessing that there's some type of diaphragm there instead of a bowl to pump the fuel out. Normally the fuel would be slightly above the engine, so it's somewhat of a gravity system. But anyways, in this choke here, this choke just runs a little flap. So the carburetor itself doesn't have a choke on it, just like on this Honda. That carburetor doesn't have a choke on it. The choke is built into the air box. So, but I'm getting ready to see if I can start this, just on the bench without the inverter, and I'll run the throttle manually and see how it runs. And then from there, I think we're going to hook up a scope to these wires and see what kind of voltage and frequency we're getting out of here. We probably won't do anything with the DC here. This is just control panel. What I was trying to do, I already tried it once. I put a just an 80 amp brushless speed control that I hooked up to these 3 wires with a 4S cell, and it did not spin the engine, but it did make a little bit of noise. So I'm not sure how many volts I need to spin that, but I should be able to spin that motor there using the generator head if I get the voltage right, because it's just a 3-phase brushless motor. But we will see. Look in the manual. We'll get to here. You can see the stator says it's a 8 kilowatt, 420 volts, 580 hertz. So I think I just need a brushless controller that has a little higher voltage, and that thing ought to spin. So I don't know if I have to get it up to 420 volts, or if a 48 volt battery will work, or 70 volts. I don't know. I'll do some research there. Yeah, let me see if I can find oh, there's the inverter. According to the manual, even though they say it's 800 watt continuous, clearly says the inverter is 700 kilowatts. So there's a little bit of a exaggeration on the rating. But anyways, yeah, if you look at this, you can see that there's the main windings and then the sub windings. And then you have the DC windings and the ignition windings. And that little switch there, they call a spring winding, but I think that's just sending a little pulse over to the ignition module to run that MOSFET that will then trigger the spark. But anyways, see, there's a DC circuit, simply has its own windings. It comes over here to a rectifier, a fuse. There's a little resistor in there, and it's completely separate from the rest of the system. And also, the ground is not connected to the neutral, so it's I think they call that a floating neutral on this generator. Or from what I understand, a lot of generators, they're bonded, but on this one it's not. All right, when I get my oscilloscope hooked up, I will let you know what happened.